this relation, this equation ensures that our function fx passes through the origin. So here we have an additional equation you see on the screen, and this is dy by dx, and since this graph passes through the origin, so we can find the value of dy by dx at the origin. And you know, at the origin y is 0, so here 0 square minus 1 plus cos 0, and this will be 0. Okay, so we have dy by dx 0. It is neither positive nor negative, so it will not have either maxima or minima at the origin. So our option A is wrong. Similarly, option B is wrong. Now we go for the remaining two options, and for those options we have to differentiate this dy by dx one more time, and when I differentiate, see what we get. Okay, so this will be 2y dy by dx and minus sin x. Okay, and we observe that it is 0. It is 0 at the origin. Okay, now we again differentiate this one, and we have, I mean, third order differentiation, and you see on the screen, and this will be equals to 2 dy by dx whole square plus 2y d2y by dx square, and thereafter cos x. And if you observe, then it is minus 1, negative, a negative quantity. Okay, now we go in the reverse direction. Reverse direction means now I will go from the bottom to the top, and we have what we have so far. So far we have d qy by dx cube equals to minus 1 at the origin. Okay, so the same, I can write the same here. I show you the same thing can be written as d cube y by dx cube equals to minus 1 in the interval minus delta to plus delta, where delta tends to 0. Okay, this means that I am taking a very infinitesimally small interval. Okay, and for in this interval I will find the second order derivative, first order derivative, and we will find the value of the graph yx, approximate value. And you know, if you differentiate both sides, then you will have d x square, and this will be minus x plus a constant. I am going in this direction. Okay, from bottom to the top, and same should be written minus in the interval minus delta to plus delta, where delta tends to 0. Okay, and this comes performing integration, and in integration a constant is added, but d2i by dx square is 0 at the origin. Here you see. Okay, so the constant will be 0, so I have written directly there d2y by dx square equals to minus x. And again integrating, we have dy by dx equals to minus x square by 2 and some constant, but that constant will also be 0 because our dy by dx is also 0. Here you can see, can observe. Okay, so now this time we will write the same minus delta to plus delta in this interval, very small interval, and now we get y equals to minus x cube by 6, okay, plus a constant, but again this time as well the constant will be 0. This relation says that the graph passes through the origin. Okay, so we get this function in this interval, very small interval, and this function is monotonically decreasing function, so our option D is correct. And in C you see the opposite statement is written there, so this will be wrong, so our correct option is D. Okay.